Okay, in this video, we will be talking about solving logarithmic equations. So this is where we're going to apply all the length concept from converting index form to logarithmic form and vice versa, the laws of logarithms that has to do with multiplication, division, power, units, zero, change of base, reciprocal, and the likes. We're going to bring in everything together now in understanding how to actually solve logarithmic equations. And we're going to be looking at a few questions, and I want you to please follow us as we move on. So I have 3 to the power of x equals to 20. Normally from indices, what we're supposed to do is to do 3 raised to the power x equals to 3 raised to the power something. So that is 3 raised to the power what will give us 20, but that is impossible. So in this case, we bring in the rule of log. So we bring in the log, and that gives us log 3 raised to the power x equals log 20. Because we have a power, and from the law, it changes to a multiplier. So we get x log 3 equals log 20. So that gives me divided by log 3 divided by log 3. So log 3 cancels out log 3, and x gives us, so we put our fraction key and we type in log 20 divided by log 3, and that gives us 2.73 to 3 significant figures. Okay, I hope this is very clear. Okay, let's look at another question which says we should solve 7 to the power of x plus 1 equals 3 to the power of x plus 2. Now here the bases are not the same, so we do the same process by adding log to both sides. Log 7 raised to the power x plus 1 equals log 3 raised to the power x plus 2. So this gives us x plus 1 log 7 equals x plus 2 log 3. So I can decide to divide both sides by, let's say, x plus 1 and log 3. Divide these by x plus 1 log 3, so that log 3 can cancel log 3, x plus 1 can cancel x plus 1. It doesn't have to be x plus 1 log 3. You can as well do x plus 2 log 7. Just to pick one thing from the left, one thing from the right. So this gives us what? Log 7 over log 3 equals x plus 2 over x plus 1. Then you solve this to get x. Another method you can use in solving this kind of question is to say x plus 1 log 7 equals x plus 2 log 3. Then you do x log 7 plus log 7 equals x log 3 plus 2 log 3. Then you try to come up with the common terms, which will be x log 7 minus x log 3 is equal to 2 log 3 minus log 7. So here now x is common, so x into brackets log 7 minus log 3 equals 2 log 3 minus log 7. So to get my x now, I'll divide both sides by log 7 minus log 3. So 2 log 3 minus log 7 divided by log 7 minus log 3. So you put this on your calculator and you get a result. 2 log 3 minus log 7 divided by log 7 minus log 3. So to three significant figures, this will give you 0.297 to 3 SF. So this might be a faster method than this. So here you still have to continue by doing what? Log 7 divided by log 3. So you're going to have 1.77124 dot 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 equals x plus 2 over x plus 1. So you cross multiply to give you x plus 2 equals to 1.77124x plus 1.77124. So trying to collect like terms, at the end of the day, 2 will give you 0.297 to 3 SF. Okay, let's look at one more question, which is quite different from all the ones we've been doing. And that is to solve 5 to the power of 2x plus 7 into 5 raised to the power x minus 30 equals to 0 to 2 decimal places. Now, we did exponential equations under indices, and we'll have something like this. So, but the difference is that in this case now, we won't be able to get an exact result. So what do we do then? We say 5 raised to the power 2x is something as 5 raised to the power x squared plus 7 into bracket 5 raised to the power x minus 30 equals to 0. Then we let p to be 5 to the power of x, so that we have p squared plus 7p minus 30 equals to 0. So trying to solve this, we get p squared plus 10p minus 3p minus 30 equals 0. So that gives us p into brackets p plus 10 negative 3 into brackets p plus 10 equals to 0. So p minus 3 equals to 0, which implies that p is 3. P plus 10 equals 0, which implies that p equals negative 10. And since our p is 5 raised to the power x, it means we can have 5 to the power of x equals to 3, 5 to the power of x equals to negative 10. So for this, because it's equals to a negative, there will be no solution. And this will just give us what? Log 5 raised to the power x equals to log 3. And that gives us x log 5 equals to log 3, which means that x will be what? Log 3 over log 5. And what will be the result of log 3 over log 5 to 2 decimal places? That is approximately 0.68. And that is solving logarithmic equations. If you have many questions that are IGCSE standard, you can use to understand this. Thank you very much.